Okay, so thank you for this. And myself, Rahul Mishra, going to present my paper titled I Care, a multi-modal data integration approach for real-time surveillance and voice assistant to improve the infant care. So that is a vulnerable things because most of usually parents are working. So was requirement, and I fetch it out and try to resolve that. Okay, so I'm from Indian Institute of Technology, Patna, and the co-author is from Indian Institute of Technology, Varanasi. And these are the content I will try to cover in that given time. And overall, I will going to discuss in a detail my methodology, what how I have done, and I have used different modalities. Okay, so as you all are aware that human activity recognition is not a new topic. It is quite popular, and a lot number of papers have been already done. And basic methodology they adopt that is related with the either vision, means that images or video or sometimes sensors, and someone use acoustics. Some papers was discussed today also. And so that were basically a uni-model that was either requiring image or requiring, let's say, sensory input or requiring some acoustic inputs. But the problem with this was, suppose the sensor says that the child is moving, so might not be alarming, but it at the classifier part you are getting that your child is moving here and there. So, so let's say acoustic will say it is a normal walk, or a vision will say it is not normal walk. Don't worry about that. So these kind of things may happen. For example, from vision you found that the child is crying, and acoustic says that there is some outside sound why child is crying. So that kind of perspective I want to create here. So in uni model we were missing some crucial information, or there should be some misleading kind of things. So, and another challenge is that all the human activity recognition method required extensive data sets, labeled data set. But in case of infant or child, this data set is limited because we are having concern with the privacy related to the children. And even with this paper, there were some questions with this. And this was the, so human activity recognition for adult is fine, but for infant it has become more challenging. Okay. So another scenario is that infant monitoring. So what usually parent did, they keep on their child with the caretaker or caregiver, and they move ahead for the offices. Then what will happen, basically what is the behavior of the caregiver, how we can monitor or control, or how we can say check out the real time behavior of our infant. So basically my target was the infant in the walker, but it can, the work can be extended for other activities also. So this point to ensure the safety and timely response. So this system not only inform you what is the condition of the infant, but also provide you the mechanism of interacting with your infant. Okay. So, so here, this is last line written, there's demand a large amount of labeled data. So how this will come? So I will try to overcome this situation using some already existing data sets, or from YouTube also I have collected some data. So, so now when you have data, then I have discussed, we have three parameters: vision, sensor, and acoustic. How to combine them and get a relevant information from them, that is another challenge. So I try to adapt this in my approach. If you see here, this is goes like this. So your child is in walker and different color indicating the different corresponding pairing of the parent. So now the walker have acoustic senses to sense the sound, and also it keeps on capturing the image. And a sensors is also placed whether walker is moving smooth or there is some alignment difference or not. And these information are placed to the server. So server could be your local machine in the apartment or buildings where multiple childs are connected, and this information is conveyed to the parents, the resultant class labels. So conveyed to the parents using some conventional IP network. So what happened basically, when you have a class label, suppose this system is saying that your child is crying, its face is smiling, and sensor is saying the motions are. So now the thing is that how we will get what actual information we want to convey. So in that scenario I uses the LLM, and that creates a message, a specified message that is transmitted to the parent. So that was the thing. And parent can now interact with the child through some speaker and all. So that was the scenario, and this scenario was totally built in the apartment in IIT Patna only, and we get a good result, and we are also exploring for further chances. So how this actually works? So here it is C2 data collection and processing is happening. So on Walker, we are not assuming a computer or laptop should be placed or a high configured devices or to be placed. It is transmitted to somewhere else where the processing will done. And here's the constant devices. Okay, so we not only bother about the, let's say, for example, a small device we have used, that is the Node MCU cam, so that capture the images. But when you are using, let's say, Bluetooth or LoRa enabled thing, then transmission of that image will be difficult. So we have divided into the patches, and patches are transmitted to the server, and accordingly we are taking. And also we also propose another thing, that is opportunistic image capture, because might be possible that once we capture an image, that will not hold the sufficient information, or your region of interest is not fulfilled, then you need a recaptured. So recapturing is opportunistic, not always, so that the limited bandwidth between Walker and the local server is utilized. Okay. And we also detected and classify sound, that we will discuss, using the 2-parameter amplitude and frequency of whether it is coming from left or right, or whether it is coming from far or near. And also the linear displacement and angular velocity, that was a simple mechanism using IMU sensors we have utilized. And the last part was that concatenating all the labels and classes in form of a message, so that was conveyed to the parents. So that is the important part, because if you get multiple outputs, it is not gaining you the significant meaning of what actually things are happening. So now LLM, so in that part we have directly called the LLM libraries, but it could be modified further. So how these things was happening: when first data collection was done, then data was transferred to the server, some pre-processing were applied, then training and integration will happen, then this was a communication to the parent, and if parent wish, they can provide a voice assistant in this. Okay, so this was my architecture. So the lower one is the sensor architecture. Basically you can see the 6 inputs are there. These are the accelerometer and gyroscope 6 axis, so that are transmitted, and at the last we will get a class label. Then we have some initial pre-processing and threshold estimation for sound class, and we are getting, so this, whether the sound is coming from outside, inside, whether the sound is of child or caregiver. And the first one is the of recognizing the actions from the captured images, and we assume that the child is still for 1 second, then only we can predict something. Now we are having auto text generator, that will automate as per the class labels, that will generate these messages, and these messages are conveyed to the parent. Okay, so so the green line part is important, because message significance, or what message actually want to convey, should not be lost, because when we try to get directly the labels to the parent, they may be confused. So now all 3 scenarios are giving information to the parent. Okay, so as I've discussed, image transmission, you can use BLE, most popular, Wi-Fi also, or LoRa WAN also, even if the distance is larger. And what our target was to minimize the transmission time, so and also try to make the device as cheap as possible and as small as possible, so we can enable any of these techniques for transmitting the data. And so resource constraints are there with the Walker, because we can't go for a higher end devices over there, and thus we disintegrated the images into the patches. Okay, so and we assume that your local server, where this processing all outputs and class labels are generated, is a capable enough machine that can receive the input from multiple source and process your data. Okay, and with this we have employed also YOLO V8, that was also fine tuned with our scenario. And when recaptured was required, that was opportunistic, not at a regular frequency. Okay, and then if you look, so how region of interest was assigned. So this how the image is divided into different patches, and using transformer encoder we get the whether the region is a face of a infant or not. So that is the ROI and non-ROI. So this was the mechanism, and this was the scenario. If you look into there's a cartoon image. So there was a microphone left and right. Some speaker was also installed. So this was a miniature device. ESP32 and ESP cam were used for capturing the images, and IMU sensor was used for this acceleration, and gyroscope readings were there. Okay, so these were the some faces I have downloaded from the internet, and I have referred it properly in the paper. So these could be the expressions, and similar types of images I have captured from the YouTube for training the first phase of the posture classification. Okay, so this was the algorithm. So initially captured images were put, then we have pose were estimated, and we believe that the pose will retain for 1 second, then we can classify what the mood the child is, and then activity recognition will happen. And also for example, when a person camera not only captures the face, also capture the surrounding objects, so that were also detected in the meanwhile. So but that part was not exploited as much as the first part. And these were the behavior that we found when we were using same sound source. These were the behavior of left and right microphones in case of frequency and amplitude. And similarly, when the noise were far and near, if you say the when it is less than 30 centimeter and when it is 5 meter, the how the things were changes. Okay, and so these were two classes. Initially, the first class, if you say 1 and 2 are the classes whether it is from infant or caretaker, and second class is say that it is whether it is crying or happy, and in second part, that is a multi-class, it is a caretaker or other sources that are occurring. Okay, so for that we have estimated some of the threshold used from some existing papers, and for that we have used CNN model again. And this was the displacement how we have monitored. So this displacement is we have intuitively threshold we have taken for as per our convenience, but it will be varying depending upon the floor type and scenario where you are using this setup. So these thresholds will automatically change. So that is the two type of thresholds are there. One is the distance threshold, and other is for the falling, the gyro is working there. Okay. So there was some data. So again, I've said I have collected some type of images from the YouTube, and these were the samples collected by my nephew at home. So have motivated me for this work. So both these images were supplied for fine tuning the YOLO V8 model uh, for this behavior of what the child is action is doing. So this was, and acoustic data we have collected around for 1 or 2 months for just. So what actually, if you look back into this model, so first part was challenging. So that for that we have created captured data from YouTube and all to fine tune the Violo EV8 model. And for these two we have collected our own data. So this may be also enhanced further. So these were sample, and we have created this acoustic and sensory data from MPU 6050, that is having gyro and accelerometer, that was deployed with the Waka itself. And this was some findings. So these were some refinement, or you can say fine tuning how the classes are varying. We have 6 activity classes, and this was the how distance were impacting our performance, and recognition versus distance and steady state duration, how it impacts our performance. And the result, we also found that this was quite interesting result, that when visibility is, so we considered 3 type of visibilities in our scenario, that is low, medium and high. If visibility is low, then recaptures are required for enhancing the performance, and if visibility is high, then recaptured is not required, and when you perform recapture, the improvement in the performance is not so significant. Thus recaptured help in improving the performance or region of interest. Okay, and this was the result, how word error and sentence error rate that were basically related with the acoustics, that we were determining how it changes with the, so it increases with the distance. Okay, so that is obvious we observed. And this is the evaluation we have done when we have used just vision, because without vision our accuracy is limited, somewhere sensors is saying so these are the different modalities accuracy that is there. And when we use this vision, acoustic vision sensor, and last combination that we have used, so this that with auto text and without auto text is nothing but that the last layer that was happening. So that how the performance was enhanced. Okay, and this was the also two paper that are quite popular in this similar domain, that is babynet and ebabynet, that are using, and that was motivational paper for me also, that are using similar type, and we are exceeding because they were not used sensors and other parameters. Okay, so this concludes my things. So it's a multi-modal approach, and it also generate the text that are going to facilitate or provide you the enough information. And we are also working for how this auto text generation can be improved and more data collection can happen, because this is a what you can say control data is there. So thank you all, and I'm ready for your questions.
Thank you so much.
Yeah.
Questions from the audience. We have time for one or two of them. Well, maybe to kick things off, you mentioned, one of the hard things here is, and especially in your paper mentioning wanting to deploy this in more real environments, particularly across different environmental settings. What sort of environmental conditions or features do you think are going to be most challenging for you to sort of replicate or translate
Yes,
this
yes.
across
So
areas?
for that we are working for, because we have just checked for one scenario and the things will be changed, and how our threshold and different parameter will be tuned up as per the scenario. So that we are working on.
Cool.
Yes. Thank you.
Anything else? Alrighty, well, let's give a round of applause for Rahul. Thank you.